Hello everyone, I'm Joshua Dennis, founder and CEO of Dennistries, and today I'm going to be giving you a quick introduction video onto the system we've been developing known as LUCI, which stands for Link, Understand and Connect Intelligently, which is the home control and automation system that we've been working on, which we hope to bring to mass market sometime next year. And so this is kind of an update on where we are with our prototypes. Now, this here is what we call the standard hub, and the way our system works is that we have, each room has got a small hub, such as this, and they all link like an old-fashioned type of, or I say old-fashioned, more like the stereotypical home automation control system, back down to a central core, where all the information is contained. But we've managed to make that core much smaller by splitting the information up and putting one of these in each room. Now this is our standard sized hub, and as you can see it's got these special connectors on the side, and these connectors are all colour coded to mean certain things. A white plug means it's for lights. A white plug with a black marking on it means it is for lights, but it is non-dimmable. A red marking means it is for outputs, such as air conditioning, blinds, things such as that. And a black output is for sensory input, such as thermostats, light sensors, push buttons, things such as that. Now, as we can see here, this is our first prototype version, which has been done on what's known as a stripboard. And the way stripboards work, as you just have a look at the circuitry underneath, is that we have all these lines going along the sides. We then drill holes to separate out the lines, and then we connect them by soldering wires from one line to another. Now obviously our final versions will actually be in printed circuit boards, so it will not look like this. This is just for prototyping. So as I said, this is our prototype for the main hub, for the standard room hub. We have got power that goes in there. These are just for if you wanted to expand and put extra things plug in there, so you've got some power outputs. Here, these sets of pins are data connections. This is the data in, so this would be going to the that computer core, which is known as an MEC, or main electronic sensor, or a gateway. These two pins here are to touchpads and other sensors, and this final pin here is to what we call a slave hub, and I'll tell you a bit more about that in a moment. We've got 2 light ports, 2 output ports, and 2 input ports. Computer chip that powers it, 3 resistors to deal with the inputs because we have to ground them, and then this is a programming socket so we can reprogram it with new code if we need to, and then of course a power connector. This is the standard sized hub, so this would probably be the most commonly used size. So as I said, you've got 2 lighting zones, so if we imagine this in a bedroom situation, one of them you could have doing the lights in the corners of the room, and the other one could be doing all the other lights. And so when you hit, for example, a button which may say evening, for evening lights, it turns off all the lights which are in zone 1, but zone 2, which are just the lights in the corners of the room, they stay on but at a lower lighting level, and that's why I have 2 different lighting zones. The outputs could be for things such as air conditioning or automatic blinds, and the inputs can be for things such as heat sensors, so thermostats, so for controlling the air conditioning. If you say you want it to be set to 21 degrees, you can then have these monitor the temperature, and then when the temperature does get to 21 degrees, it turns off the air conditioning. Now, as I said, this is the standard size hub. However, there are other sizes because, of course, this is not always going to be perfect for every single room. Sometimes you only need 1 lighting zone, 1 output, and 1 input. So, for that instance, we have the smaller hub. Put that back over there. Now, the smaller hub has only got 1 lighting zone, 1 output, and 1 input. It has got an input, a data socket, and a controller data socket. But other than that, it is essentially just a smaller version of the standard hub I showed you just before. Now prior I mentioned something called a slave hub, and let me just explain that now. if we imagine a situation of a bedroom with an ensuite bathroom, what you may have is you may have a button in the bedroom called All Off. And when we press All Off, we also want the lights in the bathroom to turn off. Now, if we were doing this in normal terms, you press that button, the signal would have to be sent all the way down to that central core, then all the way back up to the bathroom. But in R1, what happens is, you press All Off on your controller, that signal is sent into that data pin and into this chip. This chip then realises that, wait a second, that doesn't need to leave this area, it's all still here. It then sends that data out the slave hub pins to this, which would be acting as a slave hub, and then it turns everything off. And so that way we don't actually need to use massive amounts of cable, just a very short, maybe 3 or 4 meter one from this hub to that hub. Now, we've designed LUCI with different levels of difficulty for people to use, and so there's 3 levels. There's the simple, where you just plug it in and it works. There's the medium, where what happens is you have a bit of assembly needed, but not a huge amount. And the medium is really what we expect to be the primary market. It's where you set this up with an app interface on your phone, and you just select, I want this one, you do it, you set it up, really nice and easy, and then you'd have to put the connectors in. Now here is a small connector that we've got. As you can see here, if we just unravel it, this is an output connector. And it's got our connector there, so we could plug it in like that. And then it has the 2 wires here, which we could then hook up to our air conditioning, for example. Now, if you have got some very basic electronic knowledge, you'll be able to wire that up, because you know that is positive and that is negative. And so that is kind of the medium level. Now, the more advanced level is when you can actually program really sophisticated things into here, but that's probably only going to be for people with a much more advanced level of understanding with technology. But these 2 hubs can facilitate both levels. Now, as I was saying before, old-fashioned systems, or the more stereotypical systems, have that gateway, or core, or MEC, main electronic sensor, whatever you'd like to call it. And LUCI can operate without one, but all your rooms will not be interconnected, they'll just be individual. But we can also have one, and this is the base of ours. And you should be getting an image up in the corner of your screen now, showing this on the floor next to a typical gateway, and you can see the size difference. So this here can take 5 rooms in, or it can take inputs from 5 switchboards. So if you've got a house with 20 rooms, you might have a switchboard that's placed on each floor, where all the rooms connect to that, and then each switchboard just connects down here, meaning that you've got even less cable, you've got cables that have to travel even a shorter distance. Now, this is just literally a switchboard. The information comes in here, goes into this chip. This chip then works out, can the information just go straight to another room? Such as, if it is just a turn a light on, this chip doesn't need to really worry about that. It doesn't have anything to do with what's happening here. It can just send that signal straight out to the next room. But if we want to do something more advanced, such as a timer, you have these boards which we stack on top. Now these work a bit like the Arduino system. They essentially just snap on top like that and stack on top. And the beauty is, again, if you're not that great with technology, it doesn't matter. These can go around either way and it doesn't affect the whole system. They will literally just clip in around either way. Put it in like that, put it down, and the system works. There's a button here which you press, which initializes the whole thing and turns it on. This board that I showed you on top here is our initial prototype for the timer. It's currently not finished yet, it's nearly done. What you have is, you've got on the timer board the data coming in from these 2 ports here. You've got your main controller chip, and then there's this chip, and there'll be more chips here which each would be doing timing. And you've got this LED indicator which will tell you if the whole thing is working properly. Now, if we go back to our standard hub, which I showed you before, this hub's got 2 lighting zones, but sometimes you've got rooms which you need to have 5 or 6, maybe even 7 circuits running on them. And 2 lighting zones just isn't enough. And rather than having to buy multiple hubs and linking them all together, we have made this. This here is our lighting extension board. Now, the lighting extension board, you may notice, does not have one of the blue terminals for attaching power. Instead, what it has is it's just got data pins. This is designed to work with a hub, as a slave hub. We've got lighting connections here. As I said, we've got the white ones for lights, 4 of those, these are dimmable, and then the non-dimmable lighting zone there, plus a blue LED indicator light to tell you that the whole system is working. So as I said, this is designed for possibly in a room you might want to have more lighting zones than what our hubs have to offer, and that's what this is designed for. Now, there is one other kind of device we have, and this is it here. This here is our what we call the high voltage output driver. Now, it's not done yet, which is why I've got the blank circuit board on top, but if I just show you, here we've got 5 outputs which can drive up to 12 volts, which is more than our standard outputs. We've got 1 input, and we've got some relays, which are these big boxes under here. And what these relays allow is for our chips, which you can see back here. If we come around, you can see there's 2 chips there, and RGB indicator lights. It allows these 2 chips which run at 4.5 volts to drive a 12 volts current. Now, it's not complete yet, which is why there are no relays on top. When the relays are added, it will be. But an example could be, here, is if you've got a room with a lot of curtains and we'll be able to drive all the curtains individually, then we'd use these high voltage outputs. Now here, we've got 2 data ports. This is designed to operate either as its own hub or as a slave hub. So we've got a connection here to either a controller or a slave hub, and then another connection there to either a controller or to a main hub. This can also be connected to our lighting board, so you could have this operating as the main hub, with the lighting board as being the slave hub here. Now, in a previous video, we have already shown you the our controller for LUCI in our last video, and that is designed to plug into our hubs here. Now, we are hoping, as I said before, to have LUCI complete towards the end of this year and go on to finalising all of our marketing for next year. For sometime in about June next year, we hope to begin pre-orders and selling. As I said, that is an estimate. We can't say for certain. That is our aim. Anyway, I hope you did enjoy this video. It gives you a bit of an insight into what we're working on as some of our prototypes. Again, if you want to get the most up-to-date information, then of course just take a look on our website, YouTube, Facebook and Instagram channels to get the most up-to-date and accurate information on what we're working on. As I said, all updates are posted first on Instagram and Facebook, then our website, then our YouTube. So thank you everybody. I hope you enjoyed this video and that you have a great day.